It has become clear that in recent years, climate change has caused problems such as wildfires to grow ever more common. Despite these problems continuing to get bigger and bigger, our methods of fighting them remain outdated and inefficient. Thankfully, we have come with a revolutionary solution to continue to fight these fires effectively, using the fire foam turret.
Higher temperatures and longer dry seasons create conditions where fires can ignite and grow more rapidly. This is a big issue here, especially in the Okanagan, where fires can cause great harm. This map shows wildfire danger levels and active fires across Canada. Western Canada is experiencing the most intense activity, with many fires out of control. Hot and dry weather is making these fires spread quickly and harder to contain. According to the Government of Canada, by 2040, wildfires will last about 30 days longer, occur 25% more often, and burn 46% larger areas in comparison to the 1990s. The impacts go beyond burnt land, affecting biodiversity, carbon balance, local economies, and Indigenous communities.
The requirements we have is that we need lightweight, cost-effective materials, as well as we need it to be ready at any time's notice, as this is needed for emergency situations. Taking in these specs and the requirements, we need this to be able to be used in real-world problems to help fires.
There are many modern methods to fighting wildfires. However, the two methods deemed by far the most efficient involve using aircraft such as planes or helicopters. The planes, or VLATs, very large air tankers, drop fire retardant over an area to stop or at least to reduce the rate of spread of fire from one area to another. The other method involves using helicopters that fly over large bodies of water such as lakes, rivers, streams, or ponds to pick up water and drop it directly on the fire to put it out in a small area.
Our group spent a lot of time looking into the biggest hurdles in aerial firefighting. We circled around several topics, but kept coming back to one singular uncontrollable variable: the wind. Wind turns a manageable fire into an unpredictable violent force that moves faster than current technology can keep up with. If you look at this clip here, you can see that even in relatively calm conditions, the water is dispersing into a fine mist and losing its density before it even hits the tree line. Just imagine how this can look in high-intensity winds. The data we found is staggering. In high winds, the amount of agent that actually hits the target can be as low as 20%. We realize that as long as we're relying on gravity-based drops, the wind is always going to win.
Here we have the shooter in SolidWorks. It has a main gear at the top, which is attached to the top plate by certain securing panels, and the motor under, connected to the rotating gear. Inside this motor is a spindle, which we can adjust the rate of speed as which it shoots the projectiles. As you can see, the device spins 360 degrees, allowing it to aim anywhere and shoot projectiles at any velocity to protect from fires.
This is our prototype, powered by an Arduino. It's controlled by stepper, servo, and DC motor, and uses input from a joystick. This is mounted on the bottom of any firefighting aircraft, making it versatile to work on planes and helicopters. Precision shooting is the goal, so we use the stepper motor to control the yaw angle, a servo to control the pitch, and a DC motor controlled by the L293D motor driver to control speeds using PW input real time. Ideally, we'd use cameras and select a target. By using PID controls and relative plane speed, we could accurately hit a target, but for the prototype, we just use a joystick. Through a hopper, balls filled with the fire retardant or water would be placed into the shooter. No matter the direction or the speed of the aircraft, it would hit the target accurately.
This technology doesn't just improve fire safety, it revolutionizes it. By automating the response, we're improving both the effectiveness and the efficiency. The prototype is functional and the logic is proven. Now we're looking for the right partners to make this a global reality. Join us in the way we are revolutionizing the way we fight fires.